So guys, welcome to our channel once again. In today's video on our WAEC physics exam revision series, we have here these 10 WAEC related questions to answer on the topic electric field. So guys, this video will be about current electricity, so ensure to stay till the end of this video. Let's go ahead and start with the first question here, and that's question number 1 here. It says the mouthpiece of a telephone handset converts A. Sound energy to electrical energy. B. Electrical energy to sound energy. C. Sound energy to radio wave. D. Radio wave to sound energy. So guys, the answer to this question is option A, and that's sound energy to electrical energy. So actually, in the mouthpiece of a telephone handset, you have sound energy coming in, and then this sound energy will be transmitted into that and then converted to an electrical form of energy which the handset can integrate. So guys, option A is the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 2 here. You can see here that we have a diagram here, and the question says calculate the effective resistance between P and Q in the diagram shown above. So guys, we're going to do this together, and then so since we have here P at this end and then we have Q at this other end, so we have to know how we can add resistors in parallel and how we can also add resistors in series. So for the resistors in parallel here, these two resistors can be gotten. So since it's 2 ohm, 2 ohm, we can just resolve this by doing 2 times 2 over 2 plus 2. So since they are in parallel, so let's go ahead and do this together. So let's say R total is equal to 2 times 2 here over 2 plus 2. So remember, we are just doing R1 times R2 over R1 plus R2. So this will give us 4 over 4, which is equal to 1. So in this case, we have 1 for the parallel resistors. Now, so we are going to add the sum of these parallel resistors together with the resistor over there to make it series. So let's go ahead. The total resistance now across this area will now be R here will be 3 ohms here, which is the first resistance. Now we've seen the sum of these resistance here is 1, so that's 3 ohms plus 1 ohm, and that's 4 ohms here. So guys, the answer to this question is option B. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 3 here. It says the diagram below illustrates the conversions of a galvanometer of resistance 2 ohm to an ammeter. So the galvanometer gives a full scale deflection for a current of 10 milliamps. Calculate the value of R. Alright, so the first thing we'll do is to state out our parameters here. So over here, the current of the galvanometer here is going to be 10 milliamps, and you already know that 10 milliamps is 10 over 1000 amps, and that's 0.01 amps. So that's the current here, and But here again, we notice that the input current here is 10 amps. So to get the current across here, we're actually going to have 10 amps minus 0.01 amps. That's 9.99 amps. So that will be the current across. That will be the current across here. So again, the resistance of the galvanometer here is given as 2 ohms. So let's write this as RG here, given as 2 ohms. And then we have to find the resistance across here. So we're going to call that RS. And then that's the resistance we are looking for. So, and that's the resistance in the shunt. So with this, we already know that the voltage in galvanometer will be equal to the voltage in the shunt. So recall that V is equal to IR. Now if V is equal to IR, it means that I in the galvanometer times R in the galvanometer is equal to I in the shunt times R in the shunt. Well, I in the galvanometer is already given as 0.01 from our calculation here. We have 10 milliamps, that's 0.01 amps. So G in the galvanometer is given from the question as 2 ohms. So this would be 0.01 times 2 here, and that's equal to, well, I in the shunt here is what we just calculated for here, and that's 10 amps minus 0.01, that's 9.99 amps. So we're going to write this down here, 9.99, then times RS, which is what we are looking for, that's the resistance of the shunt. Now to get this, we just divide both sides by 9.99. So in that case, RS is going to be 0.01 times 2, then all over 9.99. So this will be 0.02 over 9.99, and this will be 2 times 10 to the power of negative 3 ohms. And that's option B here, guys. So option B is the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 4 here. It says, calculate the amount of heat generated in an external load of resistance 8 ohms if an alternating current of peak value 5 amps is passed through it for 100 seconds. So guys, here we are going to solve this together. So let's say I naught is going to be, let's write this here, guys. I naught is going to be 5 as given here, that's 5 amps, and then R is going to be 8 ohms as given here, and then T is going to be 100 seconds as given here. So with this, I root mean square, of course, you know, is I naught over root 2. So where I naught is 5, and then so we have 5 over root 2 here. So we can actually resolve these by squaring all the values here. So over here you'll have the square of I root mean square will now be the square of I naught, that's 25, over the square of root 2 is 2. So remember that this is in amps. Also recall that the heat here will be the square of I root mean square times the resistance times the time. So with this we can get down to the answer to this question by plugging in the actual values we should have here. So this would be 25 over 2 for the I root mean square, and then times the resistance is 8 ohms, then times the time is 100 seconds, and that's it. When we multiply these out, we can actually have, in order to make this simpler, we can just cancel these out and then cancel this to be 50, and then say 25 times 8 times 50, and then we'll multiply this. We're going to have 10,000 joules. So that's option A here, guys. So option A is the answer to this question. So that's it for this question, guys. Let's go ahead and consider the next question. So that's question number 5 here. It says, which of the following instruments is used to determine the accuracy of the electromotive force of a cell? We have A, potentiometer, B, voltmeter, C, voltmeter, D, meter bridge. So guys, obviously the answer to this question is option A here, and that's potentiometer. So potentiometer is the instrument here that is used to determine the accuracy or the accurate value of an electromotive force of a cell. So that's it for that question. Actually, the potentiometer can be used to measure the EMF of a cell and then compare it with known EMF of a standard cell. So that's it for that question. So let's go ahead and consider the next question, guys. So that's question number 6 here. Question number 6 here says, 3 identical lamps, each of power 100 watts, are connected in a parallel across a potential difference of 250 volts. Calculate the current in the circuit. So guys, let's recall that power is equal to current times voltage, or voltage times current anyway. So it means that for the current here, we can make I the subject of this equation, and then we are going to have P over V. So in that case, current is going to be the power here, which is 100 watts, over the voltage or the potential difference, that's 250 volts, and that's going to be 2 over 5 ampere here. So remember, we said here we have 3 identical lamps. So in that case, the potential difference across here will be, since there are 3 identical lamps connected in parallel, we are going to have I1 plus I2 plus I3. So that will give us 2 over 5 plus 2 over 5. So notice that they are identical lamps, plus 2 over 5. So this will give us, the LCM of this is 5. So 5 over 5 is 1 times 2, that's 2. The same here, 2. The same here, 2. So that's equal to 6 over 5 here. So we're going to write 6 over 5. So guys, 6 over 5 is 1.2 ampere. And that's it for this question. So the answer to this question is option C here. So let's go ahead and consider the next question, guys. So that's question number 7 here. It says, which of the current voltage characteristics shown below is exhibited by an ohmic conductor? So guys, the answer to this question here is option C. The graph here in option C shows the characteristic that is exhibited by an ohmic conductor. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 8 here. It says, an electric lamp rated 120 watts is used in a 240 volts root mean square. So calculate the resistance of its filaments. So guys, what we are just going to do here is to actually recall that, first of all, we have to place some equations here. We know that power is IV, right? But then again, we know that we don't have I here, so we are not looking for I, rather we are looking for R. But we know that V is equal to IR. So with this, you can simply substitute I to be V over R. So P is going to be V squared, that's V times V over R. So in that case, R alone is going to be V squared over P. So let's write it here. R is V squared over P. V squared is going to be 240 squared. So that's 240 squared over P here is 120. So that will give us the resistance here. So 240 squared over 120 here. So let's go ahead and check this out. So we're going to have R here to be 576 times 10 to the power of 2, and this over 120. So when you divide this, you'll get that R 480 ohms, and that's option D here, guys. So that's the answer to this question. Let's go ahead and consider the next question. That's question number 9 here. The question here says, during the electrolysis of copper 2 tetraoxosulfate 6 solution, an ammeter shows a steady current reading of 1.0 amps for 30 minutes, while 6.6 times 10 to the power of negative 4 kilograms of copper is liberated. Calculate the error in the ammeter reading. So let's take that the electrochemical equivalent of copper is 3.30 times 10 kilogram per coulomb. So here the first thing to do is to actually get down the equation that we're going to use. We know that M is equal to ZIT. So where M is the mass here, and then Z here is the electrochemical equivalent of the element here, and then I is the current, and then T is the time. But guys, here we are looking for the current, so simply go ahead and make it the subject of this equation, and current I here becomes M over ZT. So if we make this way, we are going to just substitute each variable here. So M, which is the mass here, becomes 6.6 times 10 to the power of a negative 4. So that's 6.6 times 10 to the power of a negative 4 here, and this will be over Z is given to us here already as 3.3 times 10, and then we're going to multiply this by the time, which is given to us in minutes. So we have to convert this time from minutes to seconds, and that's by multiplying it by 60. So that will be 30 times 60. But here guys, let's recall that let's just take note that there is an error here in this question. The electrochemical equivalence of this copper is meant to be 3.3 times 10 to the power of a negative 7, and not just times 10. So let's add this up here, times 10 to the power of a negative 7 here. So now 30 times 60 here, we've converted this. So when you go ahead and punch this with your calculator, you have a value of 1.111. So that's the current we are getting from here. So the error in the ammeter reading here will be the actual value here, which is 1.111 minus the error reading, that's 1 ampere, and that will give us 0.111 ampere. So that's option B here guys. So option B is the answer to this question. So that's it for this question. Let's go ahead and consider the next and the last question here guys. So that's question number 10 here. It says a current of 10 ampere passes through a conductor for 10 seconds. Calculate the charge flowing through the conductor. So guys, this is actually a very simple question, because the charge Q here is going to be IT. So all we just need here is to multiply the current here by the time here, and actually the two of them are already in the standard units, so we don't need to do any conversion. So we are going to have Q is equal to 10 here times 10 here, and that's 100. So Q is equal to 100 coulomb, and that's it for this question, option A. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community, where we'll post major updates on WAEC examination. This will help you a lot even as you prepare for your WAEC examination for the year. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.